All right, guys. In this video, we are going to talk about graphing sine and cosine functions and talking about this term of sinusoidal functions. Sinusoidal functions is just kind of relating it to sine and cosine because they are very, very similar. We're going to talk about kind of like the similarities and differences in just a moment, and kind of how we can lump them into this one category of just sinusoidal, okay? But to begin with, we're going to first of all just kind of discover what the graphs of sine and cosine look like. And so that's what you're going to see on our packet today, okay? So we're going to start off with sine, and I know that this is kind of little. Keep in mind, this guy that we're going to keep referencing is just the unit circle. So if you are having trouble seeing it on your screen, then check the unit circle that you have that we've worked on in class, and you can find the values from there as well, okay? But yeah, we're just going to run through and try to find our inputs and outputs. Now, these tables that they've got on a paper, these are basically just the inputs and outputs, like an XY table. So theta that's in here, that is acting like X, where you're using that as an input, plug it into the function. And then sine of theta is like your Y. So if it helps, you could always just say like that's for kind of like your X, this guy's kind of like your Y, just your inputs and your outputs, okay? All right, the other thing is I think that this packet is fantastic. I feel like it is missing one value, so I'm going to include an extra. So other than that, we shouldn't be having to add anything. I want to add whenever our input is 0, because I think that that's a very important feature for our graph. All right, so we're going to start off where we're just going to plug these values in, and I want you to remember that from your unit circle, the x-coordinate is your cosine, and the y-coordinate is your sine. That's why it's on the paper, so that we can look at that and find sine of whatever angle they want. So for sine of pi over 6, we're going to go to where's pi over 6 on the graph, and just grab the y value, and that's 1/2. All right, so like the one that I added, we wanted to do 0. Let's go back and do that. At 0, my y value is 0. All right, let's keep going along this. Pi over 3, look at pi over 3. My y value is square root 3 over 2. Okay, at pi over 2, our output is 1, because sine, again, is that y value. Look at the y coordinate. 2 pi over 3, we got root 3 over 2. At 5 pi over 6, our y value is 1/2. At pi, my y value is 0. So again, I'm just looking at those coordinates and picking out the y coordinate. All right, 7 pi over 6, look at that y coordinate, negative 1/2. 4 pi over 3, negative root 3 over 2. At 3 pi over 2, we are at negative 1. 5 pi over 3, it's negative root 3 over 2. 11 pi over 6, we're at negative 1/2. And at 2 pi, we've made a full rotation, and my y-coordinate is 0. All right, so that just gives me inputs and outputs. And let's see what that would look like if I were to graph it on this grid down here. All right. All right, so what you're going to see about this grid is you're not seeing this labeled as X, even though that's what we typically label that as. This is theta, so it is those angle measures that we plugged in. Okay, so and everything is scaled on this horizontal axis. It is scaled by pi over 6s, just like our table was. I'm just going to go through and plot each of the points. So at 0, 0, that's our origin. Pi over 6, 1/2. Make sure that you are noticing how this is scaled on the y's as well, because 1/2, 1 is scaled by 1/2, right? All right, we got pi over 3 and root 3 over 2. Now, if you were to plug that in a calculator, get a decimal, you're going to get a value about in here. So I'm just going to plot that. Pi over 2, we get all the way up to 1. Now it's going to start dropping. So at 2 pi over 3, it's going to drop down again to root 3 over 2. 5 pi over 6, we're at 1/2, and at pi, we're at 0. So you're seeing this whole arc. Now at this moment, you might feel like this is going to be a parabola shape, but hold on, make sure that we get the full table copied down here. 7 pi over 6, we're at negative 1/2. 4 pi over 3, it's negative root 3 over 2. 3 pi over 2, we are at negative 1. All right, and then we're going to bounce back up. And all of those values, when we plot them, you should see this kind of a wave pattern. Okay. All right, now, there's a lot of things in the world that we could apply this stuff to. Y'all, if you think about where, especially like science-wise, where do you see wave patterns like this? And the most common answers I hear from people are waves in the ocean, which, yeah, like think of like ripples out in the ocean. They do have that pattern. You think of sound waves, microwaves, anything that makes that kind of pattern where you have a little kind of ripple effect or a wavy pattern like that. You're able to actually represent those with sine and cosine functions, which is pretty cool. So anyways, I'm not going to harp on that too long, but it is a pretty useful thing to have. So here's a nice prettier one where it's been printed for us, and they've got a few things labeled. We've got some terms we need to talk about. So midline, it is this line that's halfway between the maximum and minimum values. It's horizontal, so it's going to kind of cut it in half, go through the middle, right? So on this case, it's y equals 0. Now this is the parent function, but what if we were to transform this? If we decided to move this up or down, that midline moves with it. All right, period. We've done a lot of talking about periods lately, and so you can see on this, it completes its cycle after 2 pi units. But keep in mind that if you were to horizontally stretch or compress this thing, it would end up changing that period. So just keep in mind it's not always 2 pi, especially if you're not working with your parent function. All right, a couple other terms. Amplitude. Amplitude is talking about the height of the wave, essentially. It's the distance from the midline to the max or to the min. On the parent function, you can kind of see here that amplitude, they tried to mark that here with this little arrow. So feel free to make that bolder if you wish. That's what they're trying to show right there, is that the height of that wave is 1. That's the amplitude. But again, what if I were to vertically stretch or vertically compress this? That would cause this to have a different amplitude. So they're not all the same. And then frequency, we're going to talk a little bit more about frequency in our next lesson, but it is, for now, just say it's a reciprocal of the period, and I promise we're going to talk about that a little bit more in our next video, okay? So whatever your period is, just flip it or put a 1 on top. All right. Let's talk about cosine. I'm going to get you guys started, and then I want you to pause the video and see if you can get the rest of it yourself. So we're going to see, flip the page, and this should be very, very similar. The only difference is we are looking at cosine. So keep in mind, remember that our coordinates, the x-coordinate is cosine, and the y-coordinate is sine. So when you're finding all the values in here, we got to look at the x-coordinates this time. Also, we're going to include that one at the beginning, like I said earlier, because I think it's really important to see what happens at 0. Okay? All right, so I'm going to get us started again, and then I want you guys to pause the video and try the rest. Let's see. At 0, my x-coordinate is 1. At pi over 6, my x-coordinate is root 3 over 2. Pi over 3, my x-coordinate is 1/2. So you see what we're doing here is we're just looking at that and taking the x instead of the y. All right, pause the video, give this a shot. I want you guys to finish out the table and then the graph and then come back, okay? All right, I'm going to just go through and fill this in real fast. And hopefully you guys got the same values. Okay. And then when we graph this, it's going to look a little bit different. Okay. Now, a lot of people just seeing one period of cosine, they'll look at it and say like it looks entirely different than sine. And I can understand why, because it feels different. It doesn't feel like you see an entire wave, kind of. It's some people say that they think it looks stretched out, but I want you to keep in mind this cycle is still only spanned 2 pi, so it's not stretched in any way. And I don't know, there's some people who they have a hard time seeing how they relate. So let's maybe talk about that. Visualize putting another period of this after it. Remember how it started up high, went down, and then back up. And then keep in mind, if I started that over again, I'd be going down and then back up. It's still that wavy pattern. So what is different? Why does this look so different from sine when we just see a period of this thing? Okay, and here's really the biggest thing is, where did it start? On the sine function, we saw that this thing went through the origin and it went up from there. Okay, it started on the midline and it went up. Whereas cosine started at a maximum and then just went down. Okay, it really is that simple. Other than that, they're basically the same thing. So you're going to see all the same type of features on this, where they talk about the midline, the period, the amplitude, the frequency. All of that is the same deal. It's just that you are looking at this thing maybe in a different location. So let's also visualize what this would look like if perhaps I were to take, okay, we can use one a couple different ways, but I think just because I'm on this page, I'm going to look here. What if this continued? Because it does. In theory, it would continue on this other side. Well, it hits pi over 2 on the x-axis right over here on the right. This is the maximum. On this side, it would hit a negative pi over 2. Okay? Now, here's my question. I want you to visualize what would happen if this thing scooted over pi over 2 units. If this scooted over pi over 2 units, that point right here would then be at the origin and be going up, and it would look like the sine function. What would be the difference? Nothing. Because they have all the other same attributes. So what we can kind of gain from that is this idea where we can kind of lump them into one category, because sine and cosine functions can be written as transformations of each other. They can be written as just a little horizontal shift of each other. As far as the parent function goes, all it needs to do is scooch pi over 2 units. So if you were going to look at that cosine function, it would be the same as if I shifted sine pi over 2 to the left. All right. Or you could look at it the way that I kind of showed a second ago. If I took the cosine function and shifted it pi over 2 to the right, it looks like sine. So the sinusoidal function is the idea that these two can be written in, both of them could be written as sine functions. And so we can just lump them into one category as sinusoidal. Now, still, there's some situations where it can be more simple to use a sine or a cosine, but I'm picking what you would prefer. But you can a lot of times argue more than one answer. Okay, we're going to skip over here to example 1 and actually work something. So here we have a lovely little graph, and they're just asking us to find the period, frequency, amplitude, and midline for this graph. They didn't ask if it was a sine or cosine. Now, if I was going to make my best, my best guess, or if I was going to have to write the equation of it, I think I would prefer to start off with calling this a sine function, because if you see this midline is cutting it in half, this starts on the midline and goes up. So to me, that's more reminiscent of that sine function. Now, again, that's not really important for this question, but just for future reference. All right, now, when we talk about period, we want to talk about how long does it take to complete a cycle. So let's just count from the beginning until it completes that wave pattern. Goes up, down, and then hits that midline again. Right there, that is one period. and that was pi units. Now the frequency, if you remember, we said that is the reciprocal of pi, so just flip it. 1 over pi is good. Or 1 over the period, excuse me, but it's 1 over pi. The midline is this line that cut the thing in half. Make sure that you are paying attention to how they scale that y-axis, because even though this is one line, that is being scaled by 3, which means my midline is at y equals 3. And then the amplitude is the height of the wave. So from the midline to that highest point, my amplitude is 3. Okay. All right, here's another one. Pause the video, try it yourself, and then come back when you're ready to compare answers. All right, so this one also says find the period, frequency, and amplitude in midline. So similar concept. To me, if I was going to guess which one this was, I would say it's more reminiscent of a cosine because it starts at that maximum point and then goes down. Now my midline is here at y equals 1. I can see that that's where it's going to cut it in half. Go ahead and write that since I said it. And then let's just go through. So period, we started up here at 3, went down and back up. That took pi over 2 units to complete a wave, which means that my frequency is 2 over pi. Just flip it. The amplitude, again, is the height of that wave, which is 2 units. So there we go. All right, that brings us to what if they don't give us a picture and they just give us values instead? What do we do? Well, there's some of us who are really good at doing stuff in our head, right? I am one of those people who I would prefer to see it visually to make sure that I knew what I was doing, because it just makes me feel more confident in myself. So I would suggest here to draw a picture, and just to kind of like keep from, I don't know, having to squish it. I'm going to draw it here on this little sticky note. If y'all are using a pencil, you probably can write it fine without it taking up too much space, but this pen tends to bleed a little and take up more room. All right, so I'm going to draw this thing out. They said we've got a sinusoidal function has a maximum at the point pi 8. All right, I'm just going to draw a wave. Okay, pretend that looks good. And they said that we've got a maximum. We're going to say this maximum is at the point pi 8. They then said the first minimum after reaching this maximum value occurs at 3 pi and negative 2. So here this would be 3 pi negative 2. And they want to figure out what is all of the different things. So from this, what we need to do is we're going to need to find the midline. Okay, again, pretend I can draw. Now the midline is going to cut these y values in half because it's got to be the same distance between either one. So just you got to figure out where is that going to be located. Let's see, if I think of averaging those two, I'd put us at 3. Y equals 3. Let me double check. We went up 1, 2, 1, 2, 3. That's 5. Yeah, should be y equals 3. They're in the middle. So the easiest way I can say to get that midline is to say it is just average those y's. 8 plus a negative 2 divided by 2. Okay, that's 6 divided by 2 is 3. So y equals 3 would be that midline. Amplitude is the height of that wave, right? So you want to think about the distance from y equals 3 to that y equals 8. So that would be 5 units right in there. Now, period and frequency. Let's look at period. So this is only half of a period. A period has to complete all the way back up. But what I want you to think about is look at these x's. We went from pi to 3 pi. This right here was 2 pi units, but that was not the full period. Raise this up a little. The full period is a little extra, right? It's the other half of this as well. So the full period is actually 4 pi for this one. And that would cause your frequency to be 1 over 4 pi. Okay? So if you don't have a picture, you could always draw one. Some of you guys are really good at visualizing it in your head, but still show me what is the math that you have done to get the numbers, just like with midline. How did we get the number there? How did you get the period, right? Show me that you added 2 pi to plus 2 pi. If you don't draw a picture, show me something, right, as to how you got your answer. All right, guys, for this video, I'm actually going to say I think we're going to stop here because, well, no. I think we're just going to continue. Let's just charge on through. Here's the deal. On level class, you do not have to watch the rest of the video because this is something we're going to talk about in AP thing. So online, if you don't want to watch the video, that's perfectly fine. And AP, let's make sure that you push on through. Okay. So let's do that. So that way I don't have to make 2 separate ones and upload multiple. All right. So here we go. This is a very similar question to what we saw in our last lesson where we had this clock on the wall. We actually have all the same values, the exact same scenario. The only thing that's different about this problem is the questions that are being asked. And so we should hopefully be kind of familiar with this, but just as a reminder as to what's going on here, the clock hand is 8 inches. Okay. They said that at time 0, it's pointing up. This clock is broken, so it's moving twice as fast. And so it ends up getting back to the top after 30 minutes. So down here would be T of 15. That would make this one T of 7.5. And then this guy over here, 22.5. Also, we had heights. This was 120 inches above. If this was pointing up, then the hand is actually at 128 because of that radius being 8. And if it was pointing down, the height of it was 112. Okay, so these are all the things that we had kind of talked about last time we did the question that was like this, but we do have a slightly different scenario. So we have a question here down here that talks about labeling this. It says we've got two full cycles, and I think this part is the same type of scenario. I'm just going to use this to help me use my scenario up there to transfer these values. So we're going to let this be T0. This was T30. Oops, T equals 30. All right, 15, 7.5, and then 22.5. All right, I know it's little, I'm sorry. Okay, now it had said find the coordinates, right? Now these are the same type of coordinates that we were dealing with last time, so I don't feel like I need to harp on that too much. We got 0, 128. We've got 7.5, 120. We've got J is 15, 112. K, 22.5, 120 again. And then P, 30 and 128. So again, this part's not really any different than what we had last time, but it's just good practice for us to reference back. Now this part is where it's a little bit more like what we're talking about here in this section. So they said find the period, frequency, amplitude, and midline, right? So let's just go in order. Period is talking about how long it takes to complete a full cycle, which is 30 minutes. Okay. Frequency, remember that is just the reciprocal, so 1 over 30. Amplitude is the height of the wave from the midline to that highest point, which was 8. And then we talked about the midline. That's the line that cuts this in half. And that's in half is 120. So y equals 120. Okay. All right, part C. It says find the two intervals for which the graph of h is both decreasing and concave up. So this is a little bit more challenging, just the way that they've asked this. We know it's talking about concave up. Well, there's two sections in here where it is concave up. I see concave up between G and K. And then I see it concave up again from this point to this point, which are not labeled, but we could figure that out. Okay. They said it needs to both be decreasing and concave up. So make sure that we're looking at the right place. So yes, concave up is here, but it's not decreasing the whole time. It's decreasing here, and then it's decreasing here. So I need to figure out what these coordinates are so that I'd be able to actually use those x values as well. So remember that this is going up by 7.5 for each little kind of interval here. So this is going to be 7.5, nope, 37.5, excuse me. And then this point right down here, we're going to be at 45. Okay. So the intervals, remember that the intervals are just asking for your x coordinates. So we're going to say our x coordinate from 7.5 to 15. And then we have another from 37.5 to 45. Okay? That's where it's both decreasing and concave up. All right. That is it for this lesson, y'all. I will see you in the next one. Bye.